2.3a is all about the parent function and transformations. What is the parent function? So this is the most basic linear function. It's used to build new and similar functions. So the equation for the linear parent function is y equals x. So every other linear equation we've talked about this unit and any other one we see throughout the year, they will all be based off of this same parent function, y equals x. This is, again, the one and only one parent function for linear equations. So the slope for our parent function, well, we have this invisible 1 being multiplied by our x, so our slope is 1. Our y-intercept, or remember for your y-intercept, x is always 0. When we plug that in, we find that when x is 0, y is also 0. So our y-intercept for the parent function is the origin. To the right here, we have the graph of a parent function. Just note when you're graphing, your line should go all the way through your coordinate plane, so from one side to the other, and you should have arrows on the end, signifying that your line is going to keep going, because lines are infinite. So just a note about how you should be graphing these lines. So not all not all linear equations look like y equals x, our parent function. So the question is, how do we change the parent function? Well, we have these things called transformations. We actually have 3 of them. We have the direction transformation. We have the transformation talking about how gradual or steep our line is. And we have our third transformation talking about the change in the y-intercept. So when we are looking at our slope controls or tells us about 2 of these transformations. The first one is the direction. So that's talking about if your line is going up or going down. So is your line increasing or decreasing? Well, we've actually talked about this one. So remember, if your line is going up or increasing, that means you've got a positive slope. If your line is going down or decreasing, that means you've got a negative slope. Okay. The second thing that the slope talks about, so the direction you're looking at, if your m is a positive number or a negative number. For the second transformation, you're actually looking at the value of that number. So remember, for our parent function, m is equal to 1. So when we have a linear equation or that has a rate of change that's more gradual than the parent function, that means that our m, our slope, is between 0 and 1. If we have an equation that is more steep than our parent function, that means our slope is greater than 1. When we're talking about gradual and steep, gradual is talking about having a slower rate of change than the parent function. Steep is talking about having a faster rate of change than the parent function. That third transformation is talking about the change in the y-intercept. So our graph can either shift up or down on the y-axis. That y-intercept doesn't have to be at 0, 0. So these are our 3 transformations: the direction of your line, how fast or slow it is changing, and that y-intercept. So how far up or down the y-axis it is. These are your transformations. Let's look at an example. So this is something called rule of 4, where we look at one equation and we talk about it, or we write it as a table, a graph, and a verbal description. So it's one equation, but we're talking about it using numerous representations. So we're starting with the equation y equals 1/3 x minus 5. Well, let's start off by graphing. So if we're looking at 1/3 x minus 5, we've got the y-intercept 0, -5, and our slope is 1/3. So we have a rise of 1 and a run of 3. So let's go ahead and graph this line. So here we have the graph of our line. Well, we can actually use our graph to write our table of values. So our table is our x and our y values. Well, I'm going to look at my graph in order to find these points. So my y-intercept, again, is 0, -5, so I can put that on my table. Well, I'm looking at my graph. It looks like I've got this point, -3, -6 that I can put on my table of values. I've got the point 3, -4, and the point 6, -3. So 3, -4, 6, -3. Whenever we're doing a table, we actually want to have 5 points. You're responsible for putting 5 points on this table. Notice how we only have 4. Actually way down here on our graph, we also have the point -6, -7. -6, -7. So we have our equation, we have our table, and we have our graph. For our verbal description, we want to be able to compare and contrast our graph to the parent function. So I'm going to draw the parent function on our graph just so we can visually see the difference. Here's our parent function compared to our equation y equals 1/3 x minus 5. So we have 3 things to talk about. The first thing we need to talk about is the direction. Notice that both of our graphs are increasing. So we can say that both graphs are increasing, or both graphs have a positive slope. Okay, that is our first transformation, talking about which direction they are going. Our second transformation, we want to talk about how gradual or how steep our line is. So our graph we're looking at, our slope is is 1/3. Our parent function has the slope 1. Well, looking back at our rules, we said that if our slope was between 0 and 1, that meant it was more gradual. And if you're looking at your lines, you can see that this red line, the line of our equation, it's going at a slower rate than that parent function is. Gradual. Last thing we have to look at is the shift on the y-axis. So again, if you're looking at our graph, the parent function y-intercept is right in the middle here at our origin, and our graph shifted 1, 2, 3, 4, 5. So it shifted 5 down the y-axis. So that's what we can put. We can say so we talked about our direction, we talked about how fast or slow our rate of change was, and we talked about that shift on the y-axis. So those are our 3 transformations. So we're done. Let's look at another problem. Well, this time we have something that's not in slope-intercept form. 3x plus 2y equals 12. So the first thing we want to do is actually write that equation in slope-intercept form. So remember from our last lesson, that means we're just going to solve for y. So let's go ahead and do that. Subtract 3x on both sides. 2y equals -3x plus 12. Then we want to divide everything by 2. Y equals -3/2 x plus 6. So this is our slope-intercept form. So I'm actually going to look at our slope-intercept form in order to graph and then use our table. Okay? Let's look at our table first. So if we wanted to do our table of values first, something we could do is pick x values and then plug them in to find y. Well, of course, we already know our y-intercept at 0, 6. Let's x value, say we want to look at -2. So if we know x is -2, well, what's y going to be? We're just going to plug that into our equation to find out. Y equals -3/2 times -2 plus 6. Well, -3/2 times -2, the negatives cancel out, the 2's cancel out. We just have 3 plus 6. So when x is -2, y is 9. All right, then we could do that again. Let's say we have x is -4. To find what y is, we're just going to plug that in and solve. So I'm going to get a different color here. Well, y equals -3/2 times -4 plus 6. Again, negatives cancel each other out. 2 and 4 simplify to 2. We end up with 6 plus 6. So when x is -4, y is +12. Okay, so again, we're just picking x values, whatever x values we want, and we are plugging them in to find y. I'm picking x values that are even because they will simplify really nicely since we have this our slope, we've got this 2 in our denominator. So that's why I'm picking slopes that are even. So let's go ahead and figure out when x is 2, what's y? When 4 is, and when x is 4, what's now when we're graphing, we actually have two choices. We could graph all of our points in this table, or we could use our y-intercept and our slope like we've been doing. It's really your personal choice, whichever one you want to do. I'm actually going to graph the points on my table. Here in the purple, I used my table of values in order to graph my line. Okay, I noticed that -412 didn't fit on my graph, so I didn't graph it. That is perfectly all right. All I needed was 2 points to draw that line. Now we're ready for our verbal description. So again, for transformation we're looking at, we are asking ourselves, well, what direction is it going in? Notice how our orange line, that parent function, it's increasing as it goes to the right. Our equation, our purple line, is decreasing. So that tells us that the direction changed. So the direction is going down since the slope is negative. So that is our first transformation. We also need to look at those other two. So each time you want to look at all three of those transformations. Well, we want to look and we want to see which one is more gradual, which one is steeper. Well, our y-intercept for our equation, our slope for our equation is 3/2. Just a reminder that when we are talking about how gradual or steep, we are just looking at the number. We don't care if it's negative or positive. Negative or positive tells us the direction. So for gradual steep, we are just looking at that number. Well, 3/2, notice that 3/2 is the same as 1 and 1/2. So 1 and 1/2 is greater than 1, which by our definition that we looked at means that this is more steep than the parent function. So just one more transformation to look at. So number 3, we're talking about that shift on the y-axis. Well, if we're comparing our y-intercepts on our equation, we shifted up 6. We talked about our direction. We talked about how gradual or steep. We talked about that shift or change on the y-axis. So we are done. So remember your parent function is y equals x, and then those 3 transformations that you need to know. How gradual or steep it is compared to the parent function, that changes in direction, so increasing, decreasing, and then that shift on the y-axis.